We're given a circle, and the general equation for a circle is x minus a squared plus y minus b squared is equal to r squared, with center AB and radius r. That can be shown using Pythagoras' theorem. So we need to take this circle and complete the square on it. So I'm just going to write it first as x squared minus 2x plus y squared plus 10y minus 19 equals 0. It's a little bit easier then to see what I'm doing when I complete the square. So when I complete the square on this, I have the minus 2. So I get x minus 1 squared. And then I need to minus 1 squared. I need to minus 1. Okay, they're the same thing. X squared minus 2x is the same as this here. And then I get y plus 5 by having the 10 squared. And I need to minus 25. Again, this is exactly the same thing. I've just written it in a different form. And then I'm minusing 19. So finally I can write x minus 1 squared plus y plus 5 squared. And when I combine these together, I'd get minus 45, so it's going to equal 45. And c is going to be 1 minus 5, because remember in the equation of the circle it's a minus, so we've got a is 1 and b is minus 5, because it's minus 5 technically. And the radius is going to be root 45. We're now told to verify that the point 7 minus 2 lies on the circumference of the circle. So I'm going to use this version. It's going to be a bit easier to deal with, less squaring needed. And this will also serve as a bit of a check for our answer. When x equals 7 and y equals minus 2, the left-hand side, what you shouldn't do is just start with the equation and show that it's 45 equals 45. Start with the left-hand side and get 45. So the left-hand side will equal, and because we're asked to show, let's take our time. Okay, you might know this is going to be 6 squared, but let's not rush it. We're asked to show, so it needs to be really convincing. So this is going to be 6 squared plus 3 squared, which is 36 plus 9, which is 45, which is equal to the right-hand side. And therefore, 7 minus 2 lies on the circumference of the circle. If it was less than 45, then it would be inside the circle. And if it would be more than 45, it would be outside the circle, because we're actually kind of finding the distance from the center to the point in question. Okay, finally, we're asked to find an equation of the tangent at this point that we've shown is on the circumference, giving our answer in the form ax plus by plus c equals 0. Definitely time for a sketch. I've not done a sketch so far, but just to get a feel for what's going on. Now remember, we have the center is 1 minus 5. So that's going to be sort of down here somewhere. We got the radius is root 45, which is going to be a bit less than 7. I'm just going to try and draw my sketch reasonably accurately. So 1 minus 5. Okay, but I think I'm going to basically get my circle going through all the axes. If it's wrong, it's not going to matter too much. Okay, I've drawn better circles, but it's quite hard to draw one in the right place, roughly, on some axes. Then I've got 7 minus 2. So that might be, say, here. And the tangent is then going to look a bit like that. Okay, so immediately we see it has a negative gradient. It just helps us if we kind of get a sketch down. And remember, we know that it goes through 7 minus 2. So I'm going to be using y minus y1 is equal to m x minus x1. And we have that x1 is equal to 7 and y1 is equal to minus 2. So the one thing we don't have is m. And that can be found by connecting up the center to the point in question. And we can find the gradient of the, not of the tangent yet, but of the line that goes towards the tangent. Actually, it's at right angles to it. It's called the normal. So we want to find the gradient of the normal. Now I'm going from 1 to 7, so I'm going 6 along. And I'm going from minus 5 to 2, so I'm going 3 up. And the gradient of the normal is going to be 3 over 6, or a half. By the way, you could get this by doing y2 minus y1 over x2 minus x1. Substitute the coordinates in, and you would also get half. And therefore, the gradient of the tangent is going to equal minus 2, because it's a negative reciprocal, minus 2 over 1, which just simplifies to minus 2. The two of these multiply to give minus 1. Since tangent perpendicular to normal. And so we also have m, it's minus 2. And so we can put that in. Y minus 2 is equal to minus 2 x minus 7. So y plus 2 is equal to minus 2x plus 14. And now remember, I'm trying to write it in the form ax plus by plus c is equal to 0. So it's going to be 2x plus y minus 12 is equal to 0. Okay, well done.